Okay, so today we are going to talk about adding and subtracting rational expressions. So we're going to start off by finding the LCM of each set of polynomials. LCM stands for least common multiple. So we're looking for the least common multiple. And what we do when finding the least common multiple is really break down each of these. So what we need to recognize is that 12, first of all, is a product of 3 and 4. 4 being a product of 2 and 2. So we can rewrite this 12a squared b is equal to 2 squared times 3 times a squared times b. And we do that for each of these. So 15 ABC is equivalent to 3 times 5 times A times B times C. And finally, 8B cubed C to the fourth is equivalent to 2 cubed times B cubed times C to the fourth. And what we want to look at here when finding the least common multiple is we are looking for, we have to have each value that we see here represented. So we have a 2, a 3, a 5, an A, B, and a C. And we have to show their highest power. It has to be the highest power of those. So we have a 2 here and a 2 here. The highest power, or highest degree, being 3. So we're going to have a 2 to the third. We have a 3 and a 3, so we can just represent that with 3 to the first. 5. An A squared, so the highest power there being A squared. B, highest power being here, B cubed. And C, with our highest power there being C to the fourth. So multiplying these all out, 2 cubed is really 8. 8 times 5 is 40. 40 times 3, so that's 120. A squared, B cubed, C to the fourth. If we look at 1b, 4 times a squared minus 12a minus 16. If you look right away, these are all factors of 4. So I'm going to go ahead and factor out of 4. If I factor out of 4, I'm left with 4 times a squared minus 3a minus 4. Factoring that further, that is 4 times, set up my two factors here, product of a squared is a and a. The second sign is negative, which tells me one needs to be positive, one needs to be negative. Factors of 4 that have a difference of negative 3 are negative 4 and positive 1. If I factor a cubed minus 9a squared plus 20a, they all have an a, so I'm going to go and factor out an a. Then I have a squared minus 9a plus 20. Setting up my factors there. Factors of a squared are a and a. Plus sign tells me they're the same, so I look at the first one, they're both minus. Factors of 20 that add up to 9 are 4 and 5. So looking at this, same thing, same concept. Each value that we have has to be represented. So we have a 4 and an a, so we know we're going to have a 4a. We have an a plus 1 times quantity a plus 1. A minus 4 is represented in both of those, but the highest degree on both of those is 1, so we only need to have it as a minus 4 to the first. And then we're going to have our final a minus 5. So this would be our least common multiple. Here's a little bit of notes that you're going to want to make sure you have in your notes. Adding rational expressions. To add rational expressions, you need to find the least common denominator. Least common denominator. So we're going to be adding fractions here, rational expressions. We always need to have our least common denominator. So for 2a, we're simplifying each expression. So we need to find our least common denominator. And to find our least common denominator, it's really helpful to know the least common multiple of those denominators. That's how we're going to find this. So between 5 and 10, my least common denominator is going to have a 10 there. My least common multiple for a and a cubed is going to be a cubed. And then I have a b squared and a b, so my least common is going to be that b squared. I need to represent my highest degree on all of these. So now what I need to do is I need to think, what do I have to multiply 5a cubed b squared by to get it to be 10a cubed b squared? The only thing I'm going to have to multiply that by would be 2. And what I do to the bottom, I also need to do to the top. So this becomes 2 times 4, which is 8. Multiplying the bottom, what do I have to get 10ab? What do I have to multiply 10ab by to get it to be 10a cubed b squared? Well, I'm going to have to multiply by an a squared so that I have that a cubed there, and by a b so that my b times b is b squared. So I'm going to have 9c times a squared, so 9a squared b times c. Adding these together, I simply add up 8 plus 9a squared bc, writing it as one fraction, as 10a cubed b squared. Moving on to b here. What needs to be my common denominator? Well, there's no common multiple really of 16 and 5. So my least common multiple is simply going to multiply 16 times 5. If you want to think like we were with that first slide, you can recognize that 16 is 2 to the 4th. So you can have this as 2 to the 4th b squared, and this being 5a cubed b. My least common multiple between those two is going to be a 2 to the 4th times a 5 times an a cubed and then a b squared. 2 to the 4th times 5, so 16 times 5 is 80, I believe. A cubed b squared. So this is now my common denominator. Now I need to think, what do I need to multiply 3a squared by, actually, so that I had this common denominator? Well, what I need to look is, I went from 2 to the 4th b squared to 80, so I need to multiply that 2 to the 4th by my 5 here, so I'm going to be multiplying this 3a squared by 5. I'm going to need to include my a cubed to get that a cubed there, and my b squared is taken care of, so I don't need to multiply by anything there. Minus, well, I had for my second fraction, 5a cubed b. So my a cubed is taken care of, my 5 is taken care of, so the only thing I need to multiply by is this 2 to the 4th, or 16. And b squared. So actually multiplying these out, 3a squared times 5a, so that becomes 15a to the 5th over 80a cubed b squared minus 8x times 16x is 128 b squared x over 80a cubed b squared. Just putting this as one fraction, 15a to the 5th minus 128 b squared x over 80a cubed b squared. Alright, so now we have 5a squared over 6b plus 9 over 14a squared b squared. So let's find our least common multiple here to find our common denominator. So 6b is equivalent to 2 times 3 times b, and 14a squared b squared is equivalent to 2 times 7 times a squared times b squared. And all we're doing with these for all the least common multiples and everything is we're just factorizing it down. Factor trees, you can remember all that however you need to do it. You're finding its prime factorization. So my least common multiple between these two, my common denominator here, I'm going to have a 2. They're both to the first degree, so I can just leave it as to the first degree. A 3, a 7, an a squared, and a b squared. That will take care of everything will be represented to its highest power. So that is equivalent to 2 times 3, which is 6, times 7, which is 42, a squared, b squared. So setting up my two fractions here with common denominator of 42 a squared, b squared. I now need to think, okay, to get from 6b to 42a squared, b squared, what is missing from my 6b to my LCM here? What's missing? What's different? Well, I have a 2 represented. My 3 is represented. I'm missing a 7, so I'm going to take this 5a squared. I'm going to be multiplying it by 7. I'm missing the a squared. And I'm missing ab. For the second fraction, to go from 14a squared b to 42a squared b, well, I'm missing, if I look at my factorization there, my 2 is taken care of. I'm missing a 3. My 7s are taken care of here and here. A squared is taken care of, b squared is taken care of, so really 3 is the only thing I have to multiply by. 5a squared times 7a squared. Well, 5 times 7 is 35. A squared times a squared is a to the 4th, b, over 42a squared b squared, plus 27 over 42a squared b squared. Writing it as one fraction, my final answer is 35 a to the 4th b plus 27 all over 42 a squared b squared. Alright, so moving on here. You are going to have to factor some of these, just like the other day when I yelled at you 100 times in class, factoring, 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 factoring. So if we factor these, we can't do anything to x plus 10, that stays x plus 10, over 3x minus 15, I can factor out a 3 there, and I'm left with x minus 5, minus 3x plus 15, I can factor out a 3 there, and I have x plus 5. 6x minus 30, factor out a 6, and I have x minus 5. So my LCM here, my least common multiple, is actually really nice here. I have my x minus 5, a 3, and a 6. Well, 3 goes into 6, so 6 is there, 6x minus 5. If you notice, that is actually the same thing as my second fraction here, which means my second fraction I'm not going to have to change at all. My first one, to go from 3 times x minus 5 to 6 times x minus 5, all I had to multiply was top and bottom by 2. Well, 2 times x plus 10 is really the same thing as 2x plus 20. So I have 2x plus 20 minus 3x plus 5 becomes, or 3 times x plus 5 is 3x plus 15. So I have a 2x plus 20 plus 3x, or plus 15, or minus 2x plus 20 minus 3x. Careful when you write that you pay attention to the fact that you are subtracting this whole quantity. You're going to need to distribute that negative. all over 6 times x minus 5. So that becomes 2x plus 20 minus 3x minus 15. Subtracting both of those. So 2x minus 3x is negative x. I don't know what my computer's doing right now, sorry. 20 minus 15 plus 5 over 6 times x minus 5. You notice here I have that special case again. I have a negative x, positive 5, negative 5. So if I go ahead and factor out a negative 1 out of this top, I now have positive x minus 5 over 6 times positive x minus 5. My x minus 5s cancel out, and my final answer here is actually negative 0.6. Alrighty, so moving on here. Same situation, we need to factor. I have x minus 1 already in factored form over, factoring here. X, second sign is negative, so I know the signs are different. 1 positive, 1 negative. Factors of 6 that have a difference of negative 1, a negative 3, and a positive 2. Minus 4 over, factor out of 5, x plus 2. So my least common multiple here, my common denominator, well, it's going to have an x plus 2, because both of these have an x plus 2 in them. It's going to have a 5 from that. And it's also going to have an x minus 3. So looking here, to go from x plus 2 times x minus 3 times 5 times x minus 2, what we're really missing there is that 5. So what I need to multiply top and bottom by is 5. So this is going to be 5 times x minus 1. From this second equation here, I have the x plus 2 taken care of. I have the 5 taken care of. The one thing I'm missing is x minus 3. So this is going to be 4 times x minus 3. Simplifying here, that becomes 5x minus 5. Minus the quantity 4x minus 12, which becomes 5x minus 5 minus 4x plus 12, when I distribute this negative, over 5 times x plus 2 times x minus 3. Combining like terms, my final answer, I have 5x minus 4x, which is just x. I have a negative 5 plus 12, which is a positive 7, over 5 times x plus 2 times x minus 3. I double check, can I cancel anything out? Can I do anything more to simplify? No, that is my answer. Alright, the last one we're going to do kind of similar to this, and we're going to go on to a little bit different. I have x minus 8 over 4x squared plus 21x plus 5. Now this one's going to be a little more difficult to factor than some of the other ones we've been doing, because this one requires us to, we have a 4x squared out in front there. So remember, we need to do that a times c method. 4 times 5 is 20. So we're looking for factors of 20 that add up, factors of 20, a times c, factors of 20 that add up to be 21. Factors of 20 that add up to be 21. Well, that would be 1 and 20. So I'm going to rewrite this. I have x minus 8 over 4x squared plus 20x plus x plus 5. If you notice, this right here, the denominator, is the exact same thing there. All I did was break up that 21x to be 20x plus x. Plus 6 times this 12x plus 3 factors a little more easily. We aren't even finished factoring with that other one. So we have factor out of 3, 4x plus 1. So finishing this, factoring this first one, I have x minus 8 over, factor by grouping now, looking at 4x squared plus 20x. What do they have in common? They both have a 4x. Factor out of 4x, so I'm left with x plus 5. X plus 5, they don't have anything in common, so think of that as a 1 times x plus 5. This still becomes plus 6, so 3 times 4x plus 1. Alright, so factoring by grouping, they both have an x plus 5 here. So factoring out that x plus 5, I am left with 4x plus 1. So now that we're done factoring, now we need to find our least common multiplier, our common denominator here. So they both have a 4x plus 1. So I know I'm going to have that 4x plus 1. I'm going to have to take care of this x plus 5. And I'm also going to have to represent that 3. So taking a look here, to go from x plus 5 times 4x plus 1 to 3 times 4x plus 1 times x plus 5, the only thing I'm missing is this 3. So I'm going to go ahead and distribute. I'm going to take 3 times x minus 8. Okay. This is going to be 6 times, to go from 3 times 4x plus 1 times to be 3 times 4x plus 1 times x plus 5, I need to multiply by x plus 5. Then it's just a matter of doing the algebra and simplifying. So this becomes 3x minus 24 plus 6x plus 30. It's going to all be over 3 times 4x plus 1 times x plus 5. Adding like terms, 3x plus 6x, I get 9x. A negative 24 and a positive 30 is a positive 6. Over 3 times 4x plus 1 times x plus 5. Now the thing about this is we're not actually done, because if you notice, 9x and 6 are both multiples of 3, so I can factor out a 3 there, and I'm left with 3x plus 2 over 3 times 4x plus 1 times x plus 5, and what happens there is I can actually cancel out my 3's. My final answer then is 3x plus 2 divided by 4x plus 1 times x plus 5. Alright, so we're almost done here. And now we have complex fractions, and it looks really scary and kind of intimidating. And I know you guys hate working with fractions, so I'm going to kind of show you the method of how you can kind of eliminate working with fractions. If I have something like 1 over a, and I don't want it to be a fraction anymore, I can multiply by a, and it'll eliminate my fraction there. So that's kind of the concept of what we're going to do here. We're going to start off by eliminating our fractions, and you can either do part A in 1 step or in 2 steps. We're going to show this first. We'll do A in 1 step and B in, we'll do A in 2 steps and then B in 1 step. I see that I have an x in the denominator here, so I'm going to multiply everything in the top and everything in the bottom, because what you do to one side top, you have to do to the bottom, by x. So if I distribute x to everything, I have x minus, if I have a y over x, think about that, y over x times x over 1, my x's cancel out, and I'm left with y. Multiply everything in the denominator by x, I'm going to have x over y plus x over x. X over x is simply 1. So that's eliminated some of my fractions there. Following that same concept now, I have a y in the denominator here. inside my fraction. So I'm going to multiply every single thing in the top and every single thing in that denominator there by y, and that'll eliminate all my fractions. I now have xy minus y squared over xy times y. Think about that. X over y times y. My y's cancel out, and I'm simply left with x plus y. And that right there would be your answer. Now, you can always do it step by step like we did there. But if you recognize, you could do this in one fell swoop here. I have both a d in my mini fractions here and a c. So if I multiply everything in the top and bottom by cd, so that first one we have c over d times cd over 1. Well, my d's cancel out. C times c becomes c squared. Following that same concept, d over c times cd over 1. My c's cancel out, and that becomes d squared. Over, I have d over c, once again, times cd. We already showed that. That is d squared. And then 2 times cd is 2cd. Now, this right here and this right here could be simplified further. I'm not worried about it. That right there could be your answer. If you did want to factor it, c squared minus d squared, once again, I don't want to shout it because my neighbors are probably going to think I'm crazy, is the difference of perfect squares. If you wanted to factor that, c plus d times c minus d. If I look here, I could pull out a d out of both of those. With factor out a d, I have d plus 2c. That would be its ultimate simplified form. Alright, last slide we're going to do here, following that same kind of thought process here. I have 1 plus 2 over x divided by 3 over y minus 4 over x. What can I multiply top and bottom by to eliminate all of these fractions inside of my fractions? Well, what are my mini denominators here? Both x and y. Distributing it to everything. 1 times xy is simply xy. 2 over x times xy over 1. My x's cancel out. I'm left with 2y divided by 3 over y times xy. My y's cancel out, and I'm left with 3x minus 4 over x times xy. My x's cancel out. 4y. Finally, 5b, the last problem we're going to do. What do I want to multiply every single thing by to eliminate it? C and d. 1 over d times cd. D's cancel out. I'm left with simply c minus d over c times cd. My c's cancel out. D times d. D squared. Over 1 over c times cd. C's cancel out. Simply left with d plus 6cd. And you're done. Okay, so that is section 2. I'm asking you guys, you can work together. You can, if you have any questions, work some of these out. You now need to work on your homework for the rest of the class, and I hope you guys have a great weekend.